Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip. Today I'm going to be talking to you about putting strings on the processing canvas and also getting string input from the user. So, processing gives you a text function that lets you draw strings on the canvas the same way you draw rectangles and ellipses and things like that. It looks like this: text, string, and then X and Y coordinates. So you can use this in two different ways: by typing in a literal string like this, text, the quick lazy pig, and then the coordinates. Or you can put your text into a string variable, s, and then pass s into the text function. Either way works fine. This will draw the string with its lower left corner at xy. And you may be like, well, what's the lower left corner of a string? So it basically draws a line from xy over to width y that's a horizontal line across the screen from that coordinate you passed in, and the text sits on that line. So that means that characters basically are mostly above that line, but characters that have the descenders, the bits of the character that go below, will actually go below the line. So let's have a look at what this actually looks like in processing. So here we have a simple example. We've created a canvas, we've actually drawn a line, and then we put text on the canvas. The text is the quick lazy pig, and we've put it at 100, 150. And here you see the result. So here's our line that we've drawn, and here's the text that's drawn, and you see it basically sits on that line, but letters like Q and Y, P and G have descenders, bits that actually go below the line. But the point that we've specified here, the 100, 150, is right at this end of the line. So it's the baseline of which the text sits upon. All right. So that text was pretty small, and there's lots more text commands that we can use to control how our text looks. The first one, of course, is text size. So we pass in a number, an integer, and it's the size of the text. It's not in like point font that you may be used to, like Times New Roman point, 12-point font, or 10-point font. This is the size in pixels. So the numbers look a little bit different, but in general, the higher the number, the bigger the text. The fill command, which you've used lots already, which typically fills inside shapes, also is used to set the text color. So now we can try something like this. We create a canvas, we again draw a line under the text just to see it. We set our text size to 40, which is going to be big. We set the fill color to red, and then we draw this text. And that ends up looking like this. So now we have really big text, and it's filled in red. So it's useful to be able to figure out how big your text is going to be, especially if you're trying to put it in the right place on the screen and make sure you have enough space for it. So there's a couple of functions that allow you to do this. Text width, and you pass the string in, tells you how many pixels wide the text will be. And you need to give it the string because that will depend on how long your string is. Text accent is how tall the text will be above that baseline. So from this point up. And you don't need to give it the string because it doesn't matter how long your text is. This is actually only dependent on the text size that has been set. Text descent is how much space you need below the line to handle the descenders, like the bottom of the Q and the bottom of the Y. So if you add text ascent and you add text descent together, that's the total vertical space that your text is going to take up. And you may note that things like the capital T here and the H don't actually go all the way to the top. The text ascent is higher than these letters, and that's because it accommodates things like accents on top of letters, even if your string doesn't have any of those. So we can use this information to, for example, draw a box around a string of text. So if we want to draw a box around the text and make sure it fits exactly, we're going to have to do some calculations. We're also going to use the no fill function on our rectangle just so we don't actually block out the text so that the rectangle is not filled. Since we're going to use the string more than once, we want to store it in a variable. And that's because we're going to use the string to pass in to find out how wide the text is, and then we're going to use the string to actually print the text. So let's use a variable to store it. We're also going to store the coordinates of where the string is drawn from, so that reference point of the baseline. We're going to store that because we're going to use it a couple of times. And then we'll make variables for the width and height of the box. So over here, that's what this looks like. We create sort of a wide canvas here. We set our text size to be big and the fill color to be red. Here's our string. It's I love programming, and we're storing it in S. And here's the coordinates, which are going to be the baseline point we're going to draw the string at, 100 and 150. And then we use these three variables and draw the string. Now, we're also going to draw a little dot at these at the baseline point, the string X and string Y, just so we see where it is. We're going to draw a white dot that's a pretty thick dot. That's the stroke weight of 8. And then we'll draw a rectangle around the string. Now, to do this, we need some new variables. So string height. So how much space do we need? How big does that rectangle need to be? How tall? And so we're going to add together text ascent and text descent. And then we need string width. And so we call text width, and we pass in S, our actual string. And that tells us how wide our rectangle needs to be. And then we simply draw the rectangle. There's one little catch in here, which is that we draw the rectangle at string X, but rectangles are drawn from the top left corner, which is here. So we need string Y, which is the baseline of where the text is sitting on, minus the text ascent, which is that top portion, the top height of how tall the text is. And then our string width and string height variables that we calculated up here. And that gives us a rectangle that fits just perfectly around our text. Okay, so typing in text and using it is fine. Putting text on the canvas is fine, but we can really make our programs much more interactive and interesting if we allow the user to actually type in text and give us text to use in our processing sketches. And we're going to do this by using a built-in Java library and something called the J option pane. This is basically a dialog box that pops up and asks the user to type in something. So this may seem mostly like magic to you right now, and you don't have to totally understand how all this works. You will understand more of that if you take future programming courses, but for now, just follow these instructions. So we need to import that Java library, which is the JavaX Swing library. It's a library that gives you a bunch of user interface components. We're going to put this statement up at the top of the program. It says we want to use this library of code. Okay. And then we're going to use the J option pane dot show input dialog prompt. So this is a function that is in the J option pane library, and we're passing it in a prompt, and this is what's going to be displayed to the user. It's going to tell them what we want them to type. And we're going to get a string from the user using this. So prompt is the text that the user will see. And so this will create a dialog box with a text entry box in it, and the user can type in that text entry box. So this whole thing is a function that returns a value, just kind of like random returns a float. So this is not a function like setup or draw, which is void. This whole thing is going to return a value, and the value it's going to return is a string, of course, because the user is going to type in text. So we need to capture that string and store it in a variable like this. So we might do something like this: string name equals J option pane, show input dialog, and then some text that we're going to give it. And actually, this can't really wrap around like this. It would have to all be on one line. Okay, so here's a program that uses this. Here's our import statement, set up our canvas, set a text size, and now we do this. We get a name from the user. So string name, J option pane, show input dialog, who are you? So when the processing compiler gets down to here, it's not going to keep going here. It's going to pop up a dialog box to the user, and nothing else is going to happen until the user types in some text. Once that's happened, the text the user typed in is going to be stored in name. And now we continue executing. We set our variables for where we need our string stuff to be. We draw the text. So we're going to make it red, and we're going to put that text on the canvas. We're going to draw a rectangle around it like we did before and draw the white dot. And so this is going to look like this when we run it. The first thing that's going to happen is this dialog box pops up, and you type something in and you click OK. In this case, we typed in Grace Hopper, CS Pioneer, and now that's stored in name, and that text gets printed out to screen, and the rectangle gets calculated to fit right around it. So that gives you a sense of how you could get text from the user and use that in your program. All right, so that's using strings, getting them on your canvas, and getting text from the user. Hope that helps. Thanks for watching.